Greetings, everyone, and welcome to the Pan Future Society podcast. I am your host, Sean. Today is Saturday, November 26th, 2016. If you're in the U.S. or somewhere overseas where you celebrated Thanksgiving, I hope you had a good holiday. If you are paying attention to the news and what's going on in North Dakota, I hope you understand that Thanksgiving is not what you were told it was when you were a little kid. But we'll do the history on a different show, I guess. Welcome again to this podcast, a science and futurism podcast for beginners with training wheels on it, I guess. If you're tuning in and you are a neuroscientist or someone who programs AIs, I'd probably like to interview you, but you might find my show a little bit too baseline for your interests, unless I'm talking about some topic that you don't know anything about. So thanks everybody for joining me. Again, I am on episode 27. Did I say that already? I don't know. I'm not going to go back and check. That's all I got, so let's get right to the news of the moment. Okay, it's been a little while since I've done something about materials science, but I found a really cool article here posted in the Daily Mail. TV screens you could roll up. Scientists have created or discovered a graphene bubble that changes color as it expands and contracts, as depicted here. You can sort of picture a flat surface, and as it becomes either a convex or concave bubble, it runs the spectrum from blue to red colors. These mechanical pixels could form the basis of screens in the future, which would be more flexible, durable, and more energy efficient than current LED technology. Dutch scientists discovered this at the Delft University of Technology in the Netherlands, and it looks like the material was developed in Britain and is 200 times stronger than steel. I'm not sure if they're talking about regular graphene or this bubble specifically here, but graphene is an ultra-thin layer of carbon, just one atom thick, and they developed this structure of it so it makes bubbles, kind of a little dome. Silicon panels are pitted with small holes around 10 times the width of a human hair, which the graphene layer stretches across like the skin of a drum. You put pressure on these cavities, scientists noticed that the resulting bubbles of the graphene changed color with their size. As the pressure inside the silicon deviated, the bubbles became concave or convex, shifting how light refracted through the graphene, triggering a series of color changes. So here is, I guess, the quest for a foldable, bendable screen is an ongoing thing. There are several out there now based on OLED technology, but this one would be perhaps much more durable and energy efficient. So, in your materials science news, a type of graphene form, a graphene bubble, that changes colors when it is flexed and is a very durable material you might see used in your television or your phone down the road. And now, it came from outer space. The EM drive was back in the news this week. Yes, the impossible drive, using electromagnetic waves, in this case microwaves, to produce thrust from nothing. This thing's been popping in and out of the news quite a bit the last year, and now a paper has been published in a peer-reviewed journal, which should lend it some legitimacy. And that shows that they were able to produce thrust in a vacuum with this device Basically, in a nutshell, bounce microwaves off one end of the thing, and some photons bounce to the other end and produce thrust. A very tiny amount of thrust, much less even than an ion drive. However, over long distances in space, where there's very little gravity to deal with, a little bit of thrust over a long period of time will get you going very, very fast. What is still weird about this thing is it doesn't use any fuel. It just uses something to generate microwaves, and that's it. Now, this thing, by all accounts, violates some very basic laws of physics that are, we're talking Newton's laws going back, 300 years now. And even though they've shown it to work in this case with the testing that they did, there are some very heavy-duty criticisms of this, and I will link to an article where I was researching this primarily this week from, of all places, Snopes, the website which debunks fake stuff on the web. Also quoted some response from a physicist and writer for, Ars Technica, I think. He has some very serious issues with the methodology that they use to test it, and with some of their explanations in the paper are sort of some hand-waving kinds of things. However, the paper got published in a journal, so, I guess we're, in other circles, we're debating how legitimate journals are and if there are issues with journals, which there seem to be. Anyway, in a nutshell, the EM drive is still in the news. It maybe still works, it maybe doesn't. At this point, I think until somebody actually builds one and puts it in space and turns it on, I'm not sure we're going to know. I did have I haven't seen anybody talk about this, so because I'm not a scientist, I don't know what I'm talking about, probably. But if it generates, does its thing and generates photons, is it not just sort of a version of a solar sail? However you generate the photons, whether they're from visible light or microwaves, it's still part of the EM spectrum. And those photons run into things and push them around a little bit. So is this just a solar sail? And I don't see any mention of how much energy is put into it to make this drive. It doesn't use fuel, but you'd still need electricity to generate the microwaves, I would imagine. So I'm not sure how you do that other than solar panels. And I would be interested to see, if you put this thing up there with big solar panels to generate electricity, if the sun hitting the panels would push it just as fast as the drive itself does. But at any rate, keep your eyes open, because this thing will probably continue to be in the news for the next year or so, or more. We'll see if somebody ever actually builds one in space to see what it does. And that is your news of the moment. All right, now on to the main segment for this week. Threats from outer space. Staying in the space this week. This is going to be the first of several episodes on threats from space. Not alien invasion, but things we know for certain can happen, and in fact have happened in the past. There are several ancient impact craters on Earth that we can still see now, and these have had wide effects on the geologic and biologic developments on our planet. Any object larger than 1 kilometer in diameter could have a global effect, and even smaller objects can create a lot of damage. The Chelyabinsk meteor from a couple of years ago injured 1,500 people and damaged 7,200 buildings. It was only 20 meters in diameter, and we never saw it coming. First off, near-Earth objects. NEOs are objects, mostly asteroids and comets, whose orbit is within 195 million kilometers or less from the Sun, which is also within about 50 million kilometers of Earth's orbit. This orbit would bring any of these objects within a certain proximity to Earth, potentially crossing our path. These objects are mostly asteroids, along with comets, meteoroids, and solar orbiting spacecraft large enough to be tracked. This past January, NASA announced the formation of the Planetary Defense Coordination Office, which tracks objects larger than 30 to 50 meters and will coordinate threat response and mitigation. This, however, appears to leave objects the size of the Chelyabinsk meteor off the list. NEOs have several different classifications, and I've also seen the acronyms NEA for Near-Earth Asteroid and NEC for Near-Earth Comet used to specify this type of object. Since 1998, NASA has had a congressional mandate to find and catalog these objects. As of October 2016, the NASA program for cataloging NEOs has amassed a database of 15,000 objects. And as of November 1st this year, there are known to be 873 NEAs larger than 1 kilometer in diameter, and 157 of these are potentially hazardous to the Earth. That is, their orbit is such that it may eventually line up with ours. 1 kilometer is the size at which it is believed an impact would cause globally catastrophic results. The asteroid thought to have killed the dinosaurs is estimated to have been 10 kilometers, that's 6 miles, in diameter. It's also estimated that all but 70 of these large objects have been discovered now. I'm not sure how they know that, but my guess is that they've been looking for a while with very good instruments, and there's probably some math with gravity involved. Large objects, even if you haven't directly seen them, will have gravitational interaction with other objects. There is also scientific and economic interest in cataloging these objects. Because of their low gravity, due to their small size and low mass, it would take a lot less energy to explore them, and there are people working on ways to mine them for resources, both for use back on Earth and in our future building needs for space exploration. So, what is the actual risk of having one of these impacts happen? I'm going to give you a rundown of information straight from the nasa.gov website about the size and frequency of Earth being hit by stuff from outer space. Every day, Earth is bombarded with more than 100 tons of dust and sand-sized particles. About once a year, an automobile-sized asteroid hits Earth's atmosphere, creates an impressive fireball, and burns up before reaching the surface. Every 2,000 years or so, a meteoroid the size of a football field hits the Earth and causes significant damage to the area. Only once every few million years, an object large enough to threaten Earth's civilization comes along. Impact craters on the Earth, the Moon, and other planetary bodies are evidence of these occurrences. Space rocks smaller than about 25 meters, 82 feet, will most likely burn up as they enter the Earth's atmosphere and cause little or no damage. Or maybe not, because Chelyabinsk wasn't that big. If a rocky meteoroid larger than 25 meters but smaller than 1 kilometer were to hit the Earth, it would likely cause local damage to the impact area. We believe anything larger than 1 or 2 kilometers would have worldwide effects. At 4.5 kilometers in diameter, the largest known potentially hazardous asteroid is Totatus. By comparison, asteroids that populate the main asteroid belt between Mars and Jupiter and pose no threat to the Earth can be as big as 940 kilometers across. Those are out there in fairly stable orbits, thankfully. Now, That list is a good data thing, but as we've seen, the Chelyabinsk was a very small thing, and it did some damage. The composition of an asteroid or a comet and its density and its angle of entry into the atmosphere make a big difference. What happened with the Chelyabinsk, and has happened with others, is it exploded pretty far up in the air, and that shock wave is mostly what did the damage. Some other information I gathered from other sources about frequency of these events. A Chelyabinsk-type event has happened once about every 60 years. For larger objects, the estimates have a large span due to the number of variables, but I've seen once every 200 years or so for something yielding 1 to 2.5 megatons of damage, to once every 1,000 years or so for something doing 10 megatons of damage. The megaton comparison, I guess, is often made because we kind of understand that kind of force. Chelyabinsk has been estimated at 400 kilotons, 0.4 megatons, which is still 40 times the power unleashed by the Hiroshima bomb. It didn't do more damage than it did because it exploded about 18 miles above the planet's surface, but this was still powerful enough to be 30 times brighter than the sun, and it burned nearby observers. The 1908 Tunguska event happened over, fortunately, an unpopulated area. This object, thought to be 60 to 190 meters in diameter, depending on its density, also broke up in the air before impacting the ground, and estimates again vary, but it may have unleashed 15 megatons of force, 1,000 times that of Hiroshima. It flattened about 2,000 square kilometers of forest in a remote area of Russia. For comparison, the city of New York only occupies about 800 square kilometers. The Tunguska event was not directly witnessed by anyone and has been the subject of some conspiracy theories, probably because there's no impact crater. There was just a flattened forest, but there is no impact crater because it did not actually hit the ground. It exploded in the air, and all that force just came as waves through the air. So what about the dinosaurs? That impact still shows its effect in the Chicxulub crater, a feature that was discovered by looking for gravity anomalies in the Yucatan Peninsula. It's buried now, but its remains can be seen underground with the right equipment. This object is estimated to have been 10 kilometers in diameter, and its impact wiped out much of the life on the planet. Its impact crater in the Yucatan is 180 kilometers wide, but it is only the third largest confirmed crater. There are two much older craters at 250 and 300 kilometers wide. There are also several unconfirmed craters that have been discovered that measure up to 600 kilometers across. We go millions to hundreds of millions of years between these types of events, but they do happen, and in a galactic timescale, they happen a lot. I was actually surprised by the dozens of large impact craters I found listed when researching this episode. Anything larger than 20 kilometers in diameter for a crater is considered large, and of those dozens, the newest ones are thought to be 5 to 25 million years old. I'll link to this in the notes. One cool thing you can do at the Wikipedia page that lists these impacts is click a link to a map and map all the impact coordinates on Google Maps or another map service so you can see where all over the world all of these things have happened. It's very interesting. The threat is there, it's real, and it's the kind of thing that could end all civilization and even all life on our planet. This is where the long-term thinking comes in. The will and the willingness to do things that will help humanity survive threats from space, whether it happens next year or whether it happens 10,000 years from now. This is why we should live here and on the moon and on Mars and on the moons of Jupiter and in large colony spaceships. This is why we should preserve the genetic information from every species we can catalog and develop the technology to incubate tigers and giant redwoods on another planet or something like that. And this is why we need to spend the money now working on ways we can tackle the problem of an incoming impact. Next week, I'll cover some of the ways that we actually can do that. And no, Bruce Willis is not involved. All right, that's the show. Thank you for joining me. I appreciate you very much for tuning in or downloading or listening on YouTube. I suppose you could watch it on YouTube too, but all it is like the logo for the show, the whole 25 minutes of the show. But if you want to watch it, hey, whatever works for you. If you want to help out the show, write a review on iTunes or do some thumbs up stuff on YouTube, share the show with people, post it on Facebook. Come to the website if you would like to help out monetarily. There's donate links there, or shoot me an email. The email is sean@panfuture.org. That's SEAN, or info@panfuture, or blah-bitty-blah@panfuture. It'll all end up in the same email inbox anyway. Come to the website, that is panfuture.org. Find us on Facebook and Twitter. I say us, it's basically just me, but if you would like to get involved by doing something for the show, if you feel like there's a topic you want to cover, let me know what it is and I will talk about it. Or if you want to research some things or interview someone, or if you have something that's futurism, space, materials science, involved, nanotechnology, artificial intelligence, all that stuff. If that is your job or someone you know does that for work, let me know. I would love to interview them. I'd like to do more interviews here. All right, everybody, have a great week, and I will talk to you again in the future.